Hello everyone, this is Christian and you are welcome back to the Don't Hub channel. So in today's video, we are going to implement our logistic regression algorithm. So we are going to build or we are going to design a logistic regression model for classification. Okay. So we have our data sets here and I'll leave the link down below. So you have to first download it so that you can go along with me. Okay. So once you download the data set, this is how the data set looks. So we have a couple of columns here. The first four are our features, okay? So we have petal, sepal length, sepal width, petal length, petal width. So that's our inputs or our features. And our label is the species, which is the dependent variable, okay? So we take in these four inputs and we are supposed to, the model is supposed to classify the outputs under any of these species, which is Iris setosa, Iris vesicular, and then Iris virginica, okay? So for this and more, kindly click on the subscribe button. If you haven't liked this video, let me know your comments in the comment section and let's start. Alright, so with the project setup, you'll be using Jupyter Notebook, okay? And once you download your data set, you have to put it in the same directory as your Jupyter Notebook or Jupyter file, okay? And once you are done, you'll be good to go. So the first step is we are supposed to import the necessary or the required libraries for this project. And I'm just going to paste them right here. So we are going to be using NumPy, Pandas, JobLib for saving or storing our model after we've designed it. And we are also going to be using model selection from sklearn, which we are going to get train and test splits. Okay, so it's a function that will help us to split our data for training and testing. We'll also be using scalar standard to standardize our data sets. And we also be using logistic regression. We will also need accuracy score, confusion matrix, and then classification reports. Okay. So for this, we can just run it here. And then the next thing we are supposed to do is we are supposed to now load our data set. Okay. So we are just going to create a variable called data. And inside it, we are going to say pd read. Okay, so you can just click on the tab to get all the necessary or the functions you can use, you can call. So we are going to use read csv, okay, because it's a csv file and we are supposed to pass in the name of our file, so our data set. So when you come here, you can just copy this, the whole thing, and you paste it right here. And once you run it, we can now create a cell down here and let's visualize our data. Okay, so as you can see, we have sepal length, sepal width, petal length, petal width. Okay, and we have the species here, like how you can see it in the data, right? We can also view some information. Okay, all right. So here we have some information here. It's 150 entries. Okay, and we have 5 columns, right? And these are the columns with their data types and also the accounts. Okay, so as you can see here, you have 150 for each of them, which means our data is full, no missing values, right? All right, so from here we can now get our features and our columns separately. Okay, so oops, so I'm going to create a cell right here, and we are first going to get our features. Okay, so we are going to drop our species column, and then to be left with only our features. So data drop. Okay, and the column is species. Okay, so I'm just going to copy that. I'm going to paste it right here. See as this one. Okay, and then also our y value, so it's going to be data, and you're just going to get only the species. Okay, so here we are dropping the species from the data set. Okay, and the remaining will be stored in x, and here we are just getting the species column and store it in y. Okay, so we have our features and our label ready. Okay, so the next step is to split the data. Okay, so you are going to now split these two into training and testing values. Okay, so the first one is going to be let's say x train, and then another one for x test, y train, and then y test. Okay, and you are going to use the train test split. Okay, so you are going to call it here. We are going to pass in our y, x, and y. Okay, we are going to say test size, so test size. Okay, and we just want let's say 20%. Okay, and our random state, so random state. Okay, it's supposed to be 42 by default. Okay, so this is how we are going to split our data. So what you are trying to say is, when we take the x, okay, which is our features, we want a test size of 20%. Okay, so you take this. When you take this, get 20% for training. Okay, sorry, testing, which is for the x. So here we are trying to get 20% for testing, and for the y we are getting 20% for testing, and the remaining 80% will be for training. Okay, so for x training and then for y training. So this is how we are going to split our data. So I'm just first of all I have to run this one. Okay, good. And before we come down here, we can just visualize our x. Alright, so you see now our x is only for the features. We don't have the species. Okay, which is our label, right? And when you check for the y also, you can realize it's only that column, right? Okay, so now we can move on to our split data. So I'm just going to run this one as well. Okay, and from here we can just see x underscore train. Okay, so you can see for the training, so we are using 120 for training. Okay, and for testing we are using 30, I think. Okay, so as you can see, we are having 30 here. You can just say info to know. All right, so we are using 30 entries right here. Okay, so now we are good to go. So I'll just delete that one. So now we come to feature scaling. Okay, so we can now scale our inputs so that they will be within the same range. Okay, so that is what you are going to do next. So I'm just going to say scalar, and I'm going to create a scalar from the standard scalar. So let me just go and copy it. So standard scalar. So I'll just call this function. Oops. Right, and down here we are now going to create our scale train variable. So we will have our scale train. So let me see scale. Oops. And then it's going to be our scalar. Okay, we are going to call fit. So you can just tap here. So we have scale fit transform. We are going to pass in our x train, right? So we have same for x test. So x test train, and that one we also pass our x test. Okay, so you are supposed to scale both our train variable and then our test variable. Okay, so now we are going to run this, and now when you visualize this one, you clearly note that it's no more the same as our x. Okay, so now it's now being scaled within a specific range, right? So now it's no more like this one. So let me just run this here. So now when you look at the x train here, You see how it is, but now your skilled value or values are different, right? So now it means our data set has been scaled. And now we'll move on to initializing and then training our model, okay, which is also an interesting part. So now we are just going to create a variable for our model. We are just going to say logistic regression. So don't want to type plenty. So let's come down here. So we are going to create our model right here. And now once you've created our model, the next thing is to train our model. Okay. We are just going to do that by calling model.fit. And we are going to pass in our X train skill. Okay, so you're just going to pass in this one. So I'm just going to copy and paste it right here. Okay, and then we are also going to pass in our Y train. So oops, Y, okay, Y train, and now we can now run it. Okay, oops, yeah. So model. All right, so we've been able to train it, and now we can make predictions with them. Okay, so we can, let's say, call model, oops, model.predict, and now we will pass in the text skill. Okay, so where is it? So we are going to pass it right here, and once we run it, you see it's now predicting for us. But we can now store this in a variable. Okay, so let's say mm, y predict or something like that. So let's say y predict, which is, let's say, y predict. Okay, and now let's run it. So we've stored it inside this variable. Okay, so now the next step is going to be evaluation of the model, which is basically trying to know the performance of the model. And we will be using these kind of things like precision. So how many detected elements were relevant, which the formula uses is either true positive under estimated positive or true positive over true positive plus false negative, false positive. Okay. And we also have recall, which is how many relevant elements were detected. Right. So I will explain it to you in a second. Okay. So with this one, what it does is it takes the predicted elements for the model. Okay. So let's say the model predicted that. Let me use as basic scenario. Let's say a model is supposed to predict whether a message is a spam or not, right? So let's say out of 10, the message predicted that um six of them were spam, right? And when you check with the actual values you have, indeed all the six that the model predicted that they were spam indeed were spam. If that is the case, then your precision is 100%. Okay, maybe there could be instances that the actual data set or the actual data you have, the spam messages were actually seven, but the model predicted only six because the predictions were correct. It's 100%, right? Now, with recall, it's almost like the opposite of that. So that one, you take your data set and you count the number of true positives that are there, which is the spam messages, and then now map it to how many of them did the model actually predicted that indeed they were spam messages. Okay, so in this case, if they were actual in the actual data set, there are seven spam messages, and the model predicted six. The model won't be 100%. Okay, for recall, but for precision, it will be 100%. Okay, so it's a kind of recall takes the actual data set as a relative. Okay, so it takes that and compare the model's prediction with that. But with precision, it takes the model's prediction and then just find out if indeed they are true. Once they are true, all of them are true. It's 100%. Okay. So now with F score, it's kind of we are trying to find a basic way of judging the performance of a model. Okay. We can just combine these two into one so that we just know the F score. Okay. So this is the formula for that. Okay. Which P stands for precision, R stands for your recall. And we also have confusion metrics. Okay. So with confusion matrix, this is how it works. So let's say we have the categories, okay? So these are our species. So let's say Iris setosa, Iris vesicular, Iris virginica, right? The first one is true positive. What it means is the actual value was true. The model predicted true, okay? So it's true positive. Now, when you take the true positive, false negative, let me explain it to you in a second. The true is actually the prediction of the model, whether the model got it right or not. And then the next one, which is positive and it could be negative, means the status of the category. Okay, so in this case, let's say Iris setosa will be the positive, the rest are negatives. Okay, so bear that one in mind. If that is the case, then first the model got it right because this and that it was A and it predicted A, so it's true positive because one, the prediction was correct and the status of it is positive, so it's true, right? Now, when you move on to the next one, these are false, automatically they are negative, okay? So now let's find out whether they are true or false. The actual value is A, the predicted B, so it's false, and the status of them are negative. So the status of B is negative, so it's going to be false negative. The actual is A, it predicted C, right? So the model got it wrong, which is false. And the status of them is negative, right? Now, same implies to all of them. Okay, so when you come here, we have B, right? Bear in mind here, B here, the same thing, right? So B is negative, right? Now, the actual value is B. The model predicted A, so it's wrong. So it's what? False. And then now you ask yourself, what is the status of this? It's positive, right? The status of the predicted, which is positive. So now it's false positive. That's why we have false positive here. Okay. And let's take C for instance. Now the model predicted C, the actual value is C, right? So it's true. Now you ask yourself, is C negative or positive? It's negative. So now it's true negative. So that's how can we have these metrics. So we are going to use this to actually evaluate our model. Okay. So I'm just going to create a new cell and we will write the algorithm for that. All right, so I have the algorithm ready. So we are using our accuracy score, which we are going to pass in our y-test values or variables. We will pass in our predicted variables. So it's going to compare them, and based on that, it will get the accuracy for us. We're also going to use the confusion matrix, which we imported, to also draw the confusion matrix and also get some classification reports. So I'm just going to run this. Okay. All right. So our accuracy we got 0.96661. Okay. And our confusion matrix is this one. So when you take your time and do the calculation with this, you realize you can get this. Okay. And now with our classification report, we have our precision recall F1 score, right? And we have our accuracy to be 97%. And you can actually do the or calculate for your precision and recall as I stated. So these are some of the information we got for our reports. And yeah, so now we can basically save our model, right? Yeah. So we've been able to create our model, right? So the next thing we are going to do is to save our model. So we can now save our model by just typing model. mm, let's give it a name. So let's say file name. Okay. And inside it, let's give any file name. Let's say reg model. Okay. So reg underscore model. So this is the file name we want to give, and you're going to call the dump, which we are going to is going to help us store the model. So we are going to call our model here, and we will specify the name of the model. So which are going to use the file name. So this is actually going to save our model for us. And once it saves, I want us to print, let's say, model save successfully. Okay. right. Yeah, I think it's fine. So now I'm just going to run this one also. Okay, our model is saved successfully. And once you come here, as you can see here, we have our reg model here. So this is our model. So we've been able to design or create our model and also save it, right? So next time you can just load the model and use it. And I would like us to do a couple of things. I'm just going to write an algorithm and explain it to you. We just want to see the values for the testing, right? The testing, which is the 30 data sets. Yeah. We are done, but I just want you to know that I just want to add this algorithm so that we can just get a feel of it. All right, so I have the algorithm ready and I've indicated some comments here so that at least it could help you when you get the file. Okay, so I'm going to upload it on my GitHub page. You can just get it and you'll be good to go. But let me take a second and then explain what this algorithm is doing. So here we are trying to iterate, okay, through our sets. And we have the length here. So we just pass in the length, which is 30. So we are just going to take our X test, okay, and I iterate through it. And for each of them, we call it our inputs. Okay. So basically we are passing in our inputs, okay, and then the model will do the predictions. And whilst the model is doing the predictions, we will be printing the input features and then its values and as well as the predicted outcome and also the actual outcome. Okay. So let's quickly just run this. All right. So as you can see here, we have our input features. So we have this, which is 6.1 and then 2.8, 4.7, 1.2, right? So these are the input features, the values for the input features, okay? And the predicted outcome was this, which is iris vesicular. And then the actual output is iris vesicular. So it got it right, right? So let me try whether I can find out. Okay, I think this one I checked was around 72, 75. Okay. So let's check 75. Okay. So you have 6.1, 8.2, and then also 7.4. Okay. So when you check here, I think that's the same thing, right? So now let's check. It's iris vesicular, right? Exactly. So it means our algorithm is also working. So this just representation. I wanted to let you know how, or let you know how the testing data went. Okay. Yeah. So that's it for this video. So let me just a recap. So in this video, we're able to design our regression model. Okay. And we did that with just, I think, 8 steps. And the first was to import our libraries, load our data sets, and then get some information out of it, split our data into training and testing, right? And we also did feature scaling. And from scaling, we initiated our model and we trained our model, right? We made some predictions, saved the predicted values, and we evaluated our model. And our model had an accuracy of 0.9667, right? And the best we could have is an accuracy of 1, which is 100%, right? And we had our confusion metrics here with some classification reports. And also, we were able to save our data. And the last thing we did was to visualize the input features values against the predicted output and then the actual output. In our next video, we are actually going to implement k-nearest neighbor algorithm. I hope you really enjoyed this video. If you did, kindly click on the subscribe button. If you haven't, share this video with friends. Let me know your comments in the comment section. See you in the next video.